Effect of parameter a on exponential function y equals a times b to the power of x plus q. Let us investigate the effect of a on the exponential function. Consider the function y is equal to ab to the power of x plus q, where b is equal to 2, a is equal to 1, and q is equal to 0. It becomes the basic exponential function y is equal to 2 to the power of x, which we saw earlier. The graph of the function can be drawn. We now take the value of a as half. A is equal to half. Q is equal to 0. The function is y equals half times 2 to the power of x. We calculate the y values for different x values and tabulate the results. X is equal to negative 3. Y is equal to half times 2 to the power of negative 3 is equal to half times 1 over 2 to the power of 3, using the law of exponents that we studied earlier. Therefore, y is equal to 1 over 16, x is equal to negative 2, y is equal to half times 2 to the power of negative 2 equals half times 1 over 2 squared is equal to 1 over 8. Similarly, x is equal to negative 1, y is equal to half times 2 to the power of negative 1 equals half times 1 over 2 to the power of 1 equals 1 over 4. X is equal to 0, y is equal to half times 2 to the power of 0 equals half times 1 is equal to half. X is equal to 1, y is equal to half times 2 to the power of 1 equals half times 2 equals 1. X equals 2, y equals half times 2 to the power of 2 is equal to half times 4 equals 2. X is equal to 3, y is equal to half times 2 to the power of 3 equals half times 8 equals 4. Let us plot the points on the same set of axes. We join the points with a smooth curve. Observe that the graph of y is equal to half times 2 to the power of x is less steep than the graph of y is equal to 2 to the power of x. We now take the value of a as 2. Note that we do not change b or q, since we are finding the effect of a. The exponential function is y is equal to 2 times 2 to the power of x. We calculate the y values for different x values and tabulate the results. X equals negative 3. Y equals 2 times 2 to the power of negative 3 equals 2 times 1 over 2 to the power of 3, using the law of exponents that we studied earlier. Therefore, y is equal to 1 over 4. X is equal to negative 2. Y is equal to 2 times 2 to the power of negative 2 equals 2 times 1 over 2 to the power of 2 equals half. Similarly, x is equal to negative 1. Y is equal to 2 times 2 to the power of negative 1 equals 2 times 1 over 2 to the power of 1 equals 1. X is equal to 0. Y is equal to 2 times 2 to the power of 0 equals 2 times 1 equals 2. X is equal to 1. Y is equal to 2 times 2 to the power of 1 equals 4. X is equal to 2. Y is equal to 2 times 2 to the power of 2 equals 8. X is equal to 3. Y is equal to 2 times 2 to the power of 3 equals 16. We then plot the points on the same set of axes. We join the points with a smooth curve. Observe that the graph of y is equal to 2 times 2 to the power of x is steeper than the graph of y is equal to 2 to the power of x. We can say that the graph y is equal to a times b to the power of x is stretched vertically when a is increased. Here, a is increased from 1 to 2. Hence, parameter a causes vertical stretching of the exponential function. When a is decreased, as it does here from 1 to half, the graph becomes less steep. Remember that we took only positive values of a in this investigation. All the functions here are above the x-axis and curve upwards. What if a is negative? If we take a is equal to negative 1, the function becomes y is equal to negative 2 to the power of x. We can draw the graph of this function. It will appear as shown here. Negative 3, negative 1 over 8, negative 2, negative 1 over 4, negative 1, negative 1 over 2, 0, negative 1, 1, negative 2, 2, negative 4, 3, negative 8. Observe that the graph of y is equal to negative 2 to the power of x is a reflection of y is equal to 2 to the power of x about the x-axis. We similarly draw the graphs of y is equal to negative 2 times 2 to the power of x and y is equal to negative half times 2 to the power of x. Now we see that as a decreases from negative 1 to negative 2, the graph is vertically stretched. And when it is increased from negative 1 to negative half, the graph becomes less steep. This is the reverse of what happened for positive values of a. When a is negative, all the functions are below the x-axis and curve downwards. We can conclude that for a greater than 0, the graph of an exponential function curves upwards. For a is less than 0, the graph of an exponential function curves downwards. All the above cases involved b is equal to 2, which is greater than 1. If b is between 0 and 1, the graph curves downwards and is above the x-axis if a is greater than 0. The graph curves upwards and is below the x-axis if a is less than 0.
Need more help? Subscribe to our channel. Can't wait that long? Ask Maski to help you and let the math finally start mathing.